नमस्कार. आजच्या लेक्चरमध्ये आपण बघणार आहे इंट्रोडक्शन टू हीट ट्रान्सफर. लास्ट लेक्चरमध्ये आपण सिलेबस डिस्कशन केलेलं आहे. सो आजच्या लेक्चरमध्ये आपण नक्की हीट ट्रान्सफर म्हणजे काय आणि त्याचा आपण कसा स्टडी करणार आहे त्याचं इंट्रोडक्शन बघणार आहे. आय होप तुम्हाला सगळ्यांना स्क्रीन दिसते. ॲप्लिकेशन्स. हीट ट्रान्सफर आपल्याला लागतं कुठे, आपण कुठे कुठे वापरतो, म्हणजेच ते कुठं अप्लाय करतो. So because we are engineers, we will see and discuss only engineering applications here. First is mechanical engineering. In mechanical engineering, we have studied in thermodynamics, in basic mechanical engineering, boilers, heat exchangers, turbine systems, internal combustion engines. Internal combustion engines is your applied thermodynamics. Then in metallurgical engineering, furnaces, heat treatment of components. Then in electrical engineering, cooling systems for electric motors, generators, transformers. We will discuss all these things in detail. First is in mechanical engineering, boilers. So where this heat transfer is going to play its role in boilers is when we try to boil something, that means what? We try to add heat so that it changes its phase from liquid to gas. So in boilers, we need some arrangement, mechanical arrangement, like vessel, like you have seen different Lancashire boilers and Babcock Wilcox boiler and all. So you are familiar with the structure of it. So in boilers, you know how heat is supplied in a furnace. It could be internally fired furnace or externally fired furnace. You know the classification of boilers. So heat is being supplied in by using some mechanical arrangement so that water gets boiled. Similarly, in heat exchangers, we all know the word itself exchange means transfer of it from one media to other media, or from one end to other end. So in heat exchangers, certain arrangement is there. I think in mechanical engineering, basic mechanical engineering, you have seen something like parallel heat exchangers, counter flow heat exchangers, cross flow heat exchangers. You have just might have heard the terms. But here in this subject, we are going to discuss all the types of heat exchanging equipments in last unit. So here, as an application part of it, we are going to see the effect of heat, how it transfers from one end to other. Then in turbine systems, you all know hydraulic turbines. Similar to hydraulic turbines, there are steam turbines. So in case of steam turbines, what we do is we supply heat to water. It becomes gas in the form of vapors, or we call it as steam at higher temperatures. And as its temperature increases, its pressure increases. It is suddenly or all of a sudden expanded on a turbine, which is a steam turbine. So on that steam turbine, what we get is, because of sudden change in pressure, that pressure energy is converted into mechanical energy by rotation of the turbine. So then sudden fall of pressure also causes sudden fall of temperature, and there is heat exchange, and it becomes the application of heat transfer. In case of internal combustion engines, as we have discussed already, that internal combustion engine is your applied thermodynamics subject. In applied thermodynamics subject, you have studied in depth what is IC engine and how fuel is burned, how it is combusted inside a cylinder by using different fuels and all. And you all are familiar with the calorific value of this and that, or you might have studied that heat balance sheet in case of IC engines. So you better know how heat is being extracted from fuel and is supplied to mechanical arrangement of piston and cylinder, which extract energy from that fuel energy or heat energy. So it also plays a good role in heat exchanger. Apart from that, this direct role, you might have observed certain fins or plate like structures attached to the external side of the cylinder, so that excessive heat which is not used to produce mechanical energy is a loss or lost heat which has been carried away, which increases the temperature of cylinder, which is being carried away by the fins, and which is then dissipated, so that the whole mechanical system remains cool or cold comparatively, and the system works fine. Otherwise, what will happen? It will seize. Similar to these few examples, there are certain examples from metallurgical engineering. In metallurgical engineering, we, in your first semester subject like material science, and in second semester you have studied in second year metallurgy, we need heat treatment. So for that, what we need is heating equipment, that is furnace is used for heating. Then heat treatment of components, you have seen furnace is to only heat, but this heat causes certain changes in grain size, grain structure, lattice structures and all, and which can be modified, or we call it as heat treated. You know all phases of material through which it goes when heated, and then sudden cooling or say slow cooling like annealing or something like that, so which can be used to strengthen the physical properties or mechanical properties of a material. So that is the better use of metallurgical processes, and how heat is used, or heat transfer, phenomena of heat transfer is used in metallurgical engineering. Then in electrical engineering, we all know electric motors, generators, transformers. So what they need is, because of flow of electricity, the system resists its temperature. Now why it resists its temperature? In last lecture we have discussed, as electric current flows through it, electrons flow through it, which causes internal heat generation, and that internal heat generation causes the system to rise, or just because of internal resistance to flow. We all know electric heaters and geysers and all, so that thing at certain applications like these transformers and motors and generators, those are needed to be cooled, and that is why, and that is where we are going to provide certain extended surfaces to it, which will try to cool the systems like motors and transformers. Like in generators what we do is, we attach IC engine or some arrangement like that, such so that that heat energy is converted into mechanical energy, and that mechanical energy is coupled through some magnetic arrangement to generators which produce electrical energy. So there we can see heat transfer being used to produce electric energy. Then in chemical engineering, we also see this heat transfer where we use refineries. So what is a refinery? It's a big subject itself, so we will not go into that right now, but it refines something, so it is called as a refinery. So process equipments used in a refinery. So process equipment is again the equipment which helps to process certain things. It may be a chemical thing, it may be a food process industry, it may be something like that. So for that we need process equipments. We need to transfer the heat from certain thing, from certain object to certain thing, or to even just take simple example of say a food processing industry, like processing of milk. As we have seen in dairies, what we do is, either we try to heat, or we try to boil the milk, or we try to cool it, we try to freeze it. So for that we need certain heat exchangers, and those can be achieved through this heat exchanging equipments, and thus heat transfer can be of some use to chemical engineering also. In various chemical plants, there are, as we all know, chemical process itself, those are classified like endothermic and exothermic. So for the endothermic processes, we need to depending on the process, we need to either supply the heat, or we need to dissipate the heat which is being excessively produced. So these are some few examples of chemical engineering. Then there is nuclear engineering. So we all know nuclear fission process, we have studied it a lot of times. Then in nuclear engineering, removal of heat generated by nuclear fission process, and in liquid metal coolants, design of nuclear fuel rods, a number of things are there. So it is a big subject itself, or even we can call it as a big branch of nuclear engineering. So there we need to use this heat transfer, and we better use it. And then aerospace engineering and space technology. In aerospace engineering, uh, heat transfer is a very critical thing. Design of aircraft systems. Why it is critical is, when take simple example of an aeroplane flying at an altitude of say 10,000 feet, 20,000 feet. So what happens is, at that height or altitude, temperature is low because atmospheric conditions are like that. And then what happens is, we need to supply external heat to maintain the internal temperature, to maintain the pressure, to maintain various comfort zones inside the aircraft. This is something about comfort, but what about engines and all? Because aircraft also run on an engine, like jet engine. It might be a jet engine or something like that, IC engine. So for that, we need to again use this concepts of heat transfer to maintain the system in running condition. Then in space technologies like rockets and missiles, and maybe some space vehicles, it's again a big branch itself. So wherever there is, we can generally discuss, wherever there is transfer of heat, where there is temperature difference, there comes the role of heat transfer, and which can be used, or which will be used. So that is why it is necessary to study. We were discussing about that space technology. So particularly, there is a separate branch called as cryogenic engineering. In this cryogenic engineering, what we discuss is very low temperatures. As you can see on the screen, this temperature ranges between 100 Kelvin to 4 Kelvin. So 4 Kelvin, you might be getting the figure in degree Celsius, because we feel everything in degree Celsius, like body temperature is 34 degrees Celsius and all. So 4 Kelvin is minus, you can calculate 273 minus 273 plus 4, so it causes minus 269. 269 minus 269 degrees Celsius to minus 173, that is 100 Kelvin. If temperature is ranging in that range, and we need to do certain things in that temperature range, what we need to do is, we need to either create that temperatures by extracting the heat, or we need to maintain it at that level, or we need to maintain the surroundings at atmospheric conditions like 27 degrees Celsius or 300 Kelvin, and a particular zone which is operating or which is under study at say minus 173 degree Celsius. So there are certain needs of this cryogenic engineering in even in production, to for storage, then transportation, and utilization of cryogenic liquids. So there are a number of things we can discuss about this cryogenic engineering here. And similarly, in day-to-day life, we again see its use of in civil engineering. So heat transfer for in design of suspension bridges, then railway tracks, air conditioning, and insulation of buildings. So how it is being used for suspension bridges is, suspension bridges are suspended. Suspended means what? They are hanged to something. So what we need to take care is, whenever there is temperature change of surrounding, just like in case of say, secondly, it is written railway tracks. Railway tracks, as a railway passes through it, it expands and collapses. Similar concepts we need to consider in suspension bridges also. Then air conditioning and insulation of buildings. Air conditioning is a very big branch itself, and we are going to see it in maybe next semester. So air conditioning is removal of excessive heat or supply of heat to overcome the cold in the room. So it is conditioning of air, maintaining it at certain level which is compatible. So that also comes in air conditioning. Then there are certain things where we need insulation of buildings. Insulation of buildings maybe due to surrounding conditions, or maybe for, like, we need to have an ice plant or a room where we are storing some foods. For that, what we need is insulation. So walls are insulated using very material which is having very low thermal conductivity. Now, what is thermal conductivity? That we are going to see it, and as we go on studying this thing. So heat transfer is we have seen. I'll just go through the branches itself. It is mechanical engineering, metallurgical engineering, electrical engineering, then chemical engineering, nuclear engineering, aerospace engineering, then cryogenic engineering, and civil engineering. So these are certain things where we have discussed very few and limited things about heat transfer. These heat transfer things, they work with certain principles. They have different laws, and these laws and principles, they are derived by their modes of heat transfer. So those modes of heat transfer we are going to see now.